Hi, welcome to the EE662. So under this course, today we will look at the substation automation equipment, right? So when talking about the substation, actually we have discussed in last couple of lectures as well, how what are the substations and what are the components in the substations and how they arrange the components, and based on that there are the layout of the substation. So if you look at the physical layout of the substation, you can find many different parts of the substation, right? So uh, so you have the incoming feeder to the substation, right? So this is the incoming feeder to the substation. Okay, and then you can see depending on the bus bar arrangement, you have different types of you can have different arrangement here, but in this case you have two bus bar or the double bus bar system, right? And so you have bus bar A and the bus bar B here. Okay, and then uh, and then from here you have the power transformers, right? uh, okay, coming from there for the bus bar, and then you have the gantry here, and then the different feeders going out with all the protection and everything, right? In the substation. So in the past lectures we have discussed about we talked about these the substation layout and different equipments used in the substation, right? And other than that, you can see here you have the main control unit or main control house here, and the local control room here, and then there are some local control rooms in different parts of the substation, right? So during this lecture we will talk about the substation automation, which include the monitoring and control of the substation, right? And as you can see here, also these kind of monitoring and controls are done in different levels. So you have local control rooms and you have main control rooms, and there are different equipments used for this control and monitoring. So our main focus in this section is to discuss uh, a different the the equipment that you use for substation monitoring and control of the substation automation, right? Saying that, we will not specifically talk about different equipments from different manufacturers, but we will basically talk about the what type of characteristics these equipment have, and how they connected to each other and how they networked, and so on, right? Okay, to start with, you have this sort of the substation layout, and basically you can identify different equipments in this substation, and we can categorize these equipments based on the importance of the equipments, as well as their uh, uh, the voltages that they are connected or they are working with, right? So we have the primary equipments in the substation which are connected to different voltage levels, right? So if it is connected to a voltage level less than 1 kV, we call them low voltage equipment. And if it's connected between 1 kV to 52 kV, we call them medium voltage equipment. And it's connected to a voltage between 52 kV and 300 kV, we can call them high voltage equipment. And then if it's connected to a voltage between 300 kV to 765 kV, we can call them extra high voltage equipments. And then if it's connected to a voltage more than 765 kV, we call them ultra high voltage equipment, right? So this is sort of this voltage level can slightly change depending on the countries and depending on uh, the how they interpret this different voltage level, right? But uh, okay. And so what are the primary equipments we have in the substation? So we have the actually we discussed about these things in the past as well. So we have the switch here, right? Like circuit breaker and the disconnectors, earthing switches, and so on, right? And then we have instrument transformers, right, to measure the voltage and current. So we have the voltage transformers and the current transformers, and then we also have the power transformers, right? Uh, which are basically used to transfer the power or the step up or step down the voltage, right? And there are other primary equipment such as surge arresters, shunt reactors, series reactors, shunt capacitor banks, and etc. Which you can see in the substation depending on the substation configuration. Okay. Uh, Okay. And so medium and the low voltage components are basically used in the auxiliary power auxiliary systems like the auxiliary power transformers and the bay junction boxes and so on, right? So we will discuss about these things the detail later on, right? So here you can see an auxiliary power transformer which is uh, size wise much less than the power transformer, right? That is used in the substation. So this is basically taken for used for the auxiliary power that is utilized by the substation itself, right? And then you have the bay junction boxes. So we'll talk about this bay concept the later on, right? So that this would be something looks like this here, right? So all the connections are coming from the monitoring and control devices comes to these junction boxes, and then it goes to the corresponding the location, right? And the okay. So when you look at the primary arrangement of the substation, as I discussed earlier as well, so you have the incoming circuit in here. So for an example, this is an incoming circuit, and then so this is the power source to the substation, and they may come from any generation station or even from other remote substation, right? And then you have the outgoing circuits, right? As I have mentioned in here. So they are also called the feeders, right? So they leave power from the substation, and it's basically supply the power to the distribution system, right? And when you talk about the this bay concept, right, that's very important when it comes to the substation automation, right? So bay is basically defined as a or it is understood to be a generally a repetitive group of equipment within one voltage level, right? So if you look at this, right, so you have bus A and bus B, and then you have corresponding protection devices and the measuring devices, right? That is connecting the incoming source to these two buses, right? So all these equipments works in a same voltage. Now, for an example, if your incoming voltage is 132 kV, right? And so then this bus will also be 132 kV, and all the equipments here will also operate in 132 kV. So they all have one voltage level, right? So we can say that this is a bay, right? Or you can even take this whole thing as a bay because they all work in a one single uh, voltage level, right? Uh, Okay, so this bay is also defined as a physical section that contains the complete set of equipment required to connect a circuit, like a power line or transformer to the main bus bar. Okay, so here you have circuit breakers, disconnectors. Then you can see you have the instrumentation transformers and the earthing switches and everything, right? Connected in a single voltage level, and we call it a bay, right? And if you look at this distribution, let's say this transformer is like 132 kV to 33 kV transformer, right? And in that case, this whole system, the feeder going out, this whole system is a 33 kV system, right? So it's in a single voltage. So all these circuit breakers, the instrument transformers, and everything, right, are connected to this 33 kV system. So they are all in a single voltage. So we can. So this is also a bay of a transformer. So you can see the substation. So you can see the substation can have many bays, right? And depending on the configuration, you can actually uh, okay, identify many different bays in the transformer. Sometimes this bay concept is widely used when it comes to the substation automation, because you can monitor and control or automate these bays individually, or as a, like, sometimes you may define these two together as a one bay, and you may have a different control and monitoring unit for that. Say for an example, this local control unit could be for this section of the substation, which all works in 132 kV, for according to our example, right? And all the control and monitoring is done in here. So it's a bay level control, right? So we can, it's all depend on how you configure and how you, you know, uh, how you basically configure your substation and how you configure the control and monitoring function of the substation, right? Uh, okay, so talking about the substation automation, so what are the control requirements you have in a substation, right? So if you look at the apparatus in the substation, so equipments in the substation, so an example, circuit breakers, right? They have they need to be commissioned, they need to be maintained, they need to be repaired, right? And the so it could be so basically you can set the open and close commands to these circuit breakers, right? For a maintenance purpose, for repair purpose, or for commissioning purpose, right? You basically can send these signals. So if you want to take for the circuit breaker out for a maintenance purpose, you can send a open command, right? Through the substation automation system, right? So if you take the disconnectors, also they have a very similar characteristic. So you can send the open and close commands to the disconnectors, right? For the maintenance purpose, repairing purpose, and sometimes for alignment of conductive blades. Okay. And if you look at the earthing switches, so you can again open or close them from the the, the command center, right? For the maintenance purpose and the repairing purpose, right? And when it comes to the power transformers, so sometimes it go beyond the little bit, this operation and maintenance stuff, right? Because now you have sometimes step changing transformer, right? And so the control unit will send the commands to automatically up or down the tap position. So automatic tap changing is also facilitated through uh, the control and monitoring system or the substation automation system. Okay, and okay. Uh, So when it comes to the substation automation, the bay level is the it's as defined by the IEC 61850. So this is one of the main standard when it comes to the substation automation, right? So this communication standard for power systems, right? So it defined the communication standard requirements in the substation automation as well, right? So according to these standards, the bay level is an intermediate control place between the switchgear boards and the main control house of the substation. So earlier you can see you have the main control house of the substation in here, right? And then you have the intermediate control uh, houses, right? So those are the bay level control, right? So at this level, the control, monitoring, and other important functions are performed from one of several local control rooms, right? Located in the so they are located inside the switchyard, right? Uh, Okay. As I said earlier, so you can identify the base in the substation, right? So base are if you identify the base, so that all the equipment in that base should be in a single voltage unit. So you can identify these local control rooms at least one per each primary voltage. Now, for an example, this side is 132 kV and this side is 33 kV. So you can identify one bay control center, right? Local control room for this part. And you can identify one local control room for this part and so on, right? And so it says at least. So if you want, you can go ahead and further divide this like if you want to separately monitor each of the feeder, right? I don't know, like it may be very expensive, but you can identify different bays and you can have control rooms. If you have large number of feeders, at least a couple of feeders together, you can have a one the intermediate control room, right? So, but at least you can have two controllers or two at least one control room or bay control for each voltage level. Okay. Uh, okay. So this control room will lodge or hold the majority of the IEDs, right? Intelligent electronic devices. We will discuss about them later, right? And relays and other secondary devices that are belong to the substation automation system. Okay. Okay. So let's take a look at this the switchyard control rooms or the bay level control rooms, right? So these control rooms they are also this building, so they are also called the local control rooms, are designed to accommodate all the cubicles needed for the operation of the substation at the bay level, right? And these control rooms typically contain the control and protection cubicles associated to the corresponding bays, right? uh, okay, and the main and the backup also, right? So you have the main controls and the backup controls, right? And any teleprotection devices, time synchronization devices, power transformer control and monitoring cubicles, right? Capacitor bank control and monitoring cubicles, and distance recorder cubicles, metering devices, right? The communication equipment, including the interfaces, right? And voltage regulating devices, fiber optic distribution cables. So all these things are located in the switchyard control room. So you may have, at least one for each bay that you have identified. Right? And so it looks like something like this, a very small room, right? With uh, the adequate devices to control and monitor the bay level equipment, right? Uh, so how many bays will be controlled by each single bay controller, right? And how many bay controllers will be allocated to a control cubicle, right? How many protective relays will be installed into a single cubicle? How much space will be required by other devices like Ethernet and switches? They all depend on the configuration of the substation and configuration of the switch yard control room, right? So the designer have the freedom to decide, how many days that you will be allocate for each control room and so on. Okay. So typically these kind of rooms will facilitate at least two or couple of doors that you can come in and go out, right? For a safety purpose, because they are located inside the switch yard. So in uh, any incidents, the operators or the people who are working in here should be able to quickly evacuate. So that's needs to be also taken into the consideration. Okay. And if you look at the in the bay control units, one of the main equipments that you have is the bay controller, right? So one of the main panels that you see here is the bay controller, right? So the bay controller is uh, is an IED, the integrated electronic devices, intelligent electronic devices. Right. So the rather than the uh, Yeah. So what is the intelligent electronic devices, right? So these devices are the devices which it could be the same old devices. Like for example, in all networks, you have these relays, right? And so they basically operate by looking at the local voltages and currents and so on, right? But you can now incorporate certain intelligence to these relays by the help of microprocessors, right? Based controllers built into these relays, protection relays, or so on, right? And so these are called the intelligent electronic devices. So it would be the similar devices, like for an example, the transformer tap changing devices, right? So now rather than going for a kind of a mechanical tap changing devices, uh, you have some intelligent tap changing devices with the microcontrollers, and they take certain decisions based on the local parameters as well as the parameter you collected from other locations, or the signals that are coming from the control units, right? And based on that, they take the decision, right? So that's why they are called the intelligent electronic devices, right? And these devices help us to automate and monitor the grid equipment, right? Like circuit breakers, transformers, and the capacitor banks, and so on, right? So so we'll come to the detail of the IEDs later. I just wanted to give you an idea about what's an IED, right? And when it coming back to the bay controllers, right? With Okay, so we have this in the bay controller. We have this IED provided with the built-in type of human-machine interface, right? Which is configured to enable the implementation of various control functions in the bay controller, right? So you can see here you have a bay controller, right? And you can see this is kind of a big controller for an outgoing feeder, like 110 kV outgoing feeder here. So you can see you have the similar feeder arrangement drawn here and corresponding metering, right? And indication and all these devices are there to monitor and control the this bay in here, right? So you basically have control and monitoring of primary switch gears, right? Like a circuit breakers, isolators, uh, uh, and so on, right? In the bay controller, right? And the bay controller also manage the interlocking logic in the substation. So we have discussed what's the interlocking logic in past classes, right? So the bay controller makes sure that the interlocking procedure will be followed, uh, properly, right? And it will display the alarms and signals to the workers who are inside the control center, right? Or local control center or the bay level control center, right? And it also do the recording and display events information, right? It records all the event information, turning on and off the circuit breakers, tap changing of the transformers, right? All the events are recorded and the variation of voltages, frequencies, and everything. And they will also be displayed through the meters and other display panels to the operators in here, right? And it will interface with the protective relays, right? Uh, and it will check for the synchronization or synchro check for circuit breaker operations, and it do the metering functions, and it interface with the upstream control facilities, right? So it is interconnected or interfaced with the upstream circuit control facilities through the communication network, right? And then like fiber optic or any other medium, and interface with other control devices like voltage regulators. Okay. Uh, Okay. So this the brake controller, they can be integrated with the different elements, right? So if you look at the brake controller, they have the power supply to supply all power to all the monitoring and control equipment in that level, right? So these power supplies are usually the DC-DC converters, right? Use the because that will help to avoid the electromagnetic interference that coming through this power supply path, right? Uh, so for redundancy, you may have a second power supply, right? And you need a communication modules uh, to communicate with the station buses, right? And the high level control rooms, right? So this could be basically electro-optical communication, right? Optical communication. So you need electro-optical converters, right? And corresponding communication port to convert the uh, the measurements and then transfer or any control signals and transfer that to the station bus, right? So we talk about the communication architecture and what the station bus is and so on later. Okay. Uh, and then you have these processing units, right? Those are the electronic module in which the application programs are installed, provided of interfaces for local control, right? And they will have a flash memory for data configuration and means to acquire information from primary equipment and exchange data with station controller. So you need a certain processing unit to facilitate all these connections and data processing, data storage, and everything, right? Uh, and you have the interconnection modules. Sorry, the interconnection module. This thing is not visible. So how to do that? Okay. Anyway. Uh, So interconnection module. So these are the units. Sorry. These are the units used to establish the internal communication between the different elements of the bay controller. Okay, and you have the communication controller. So these are the module responsible for the external communication via the station bus to the main controller, and sometimes even to the outside the substation, right? And then you have set of binary input cards. Okay, that's one set of binary input cards, right? So these are generally confirmed by the optocoupler or optic couplers to avoid any electromagnetic interference coming from the secondary circuits, right? And then you have binary output modules, right? So these often consist of auxiliary relays able to manage the power required for control commands or for of the primary and secondary switch here, right? And you have the instrumentation or instrument transformer modules, right? And then you have the single signal converter modules, which are used for convert the current and voltage analog signals to the digital signals and so on. Okay. Uh, can I use that for the time being? Right. So now, if you look at the complete signal, so you have the bay controller unit, something like this, right? This is a bay controller unit, okay? And to the bay controller unit, so you can see it have many inputs and many different outputs, right? So it basically have electrical inputs, right? Which are taking the measurements that are coming from the uh, CTs and VTs, the current transformers and the voltage transformers. So these will come directly as the electrical signals, right? So they are taken through the electrical inputs, right? And then there are some, digital input that are coming to the bay control unit. So these are basically coming from the switch cheers, right? To see whether they are open or closed, right? So the contact of circuit breakers, isolators, etc., will send a digital signal to the bay control unit to basically indicate whether they are what's the state, whether they are open or closed, and so on, right? So and then this bay controller unit also accept the analog inputs, right? And these analog inputs are basically coming from the other analog sensors. Now, for an example, temperature sensors, tap position sensors, and etc., which are connected to the particular equipments in that the bay or the substation, right? So typically these analog inputs could be the current inputs or voltage inputs. So typically the current inputs are ranging from 4 to 20 milliamperes, while the voltage signals are ranging from 0 to 10 volts. So these are the standard levels that are accepted by any data acquisition systems, right? And then you have the inputs that are coming from the SCADA system. So basically the control signals that are sent by the corresponding operators who is looking at the SCADA systems. And say, for an example, if they want to change the tap or if they want to open a circuit breaker for a maintenance purpose, they will send a corresponding command. So these are coming through the SCADA system as a communication using some sort of a communication protocol, right? Agreeable by bay controller unit and the SCADA system. So these are basically coming through the communication ports in the SCADA system. So this SCADA system supports many different types of communication port like RS485 and optical fiber, Ethernet, and so on, right? Uh, so they depend on the bay controller unit. Okay. So what's basically happening here is, okay, so these bay controllers collect all this information, right? And there will be some commands initiated by the human machine interface or this SCADA system, right? And this will go to the bay controller unit. And the bay controller unit, basically it has a CPU, okay, of the in the bay controller unit, or the processing unit is there. So this processing unit of the bay controller unit will process this command, right, and identify, okay, for what is this command, and for what device this command is, and so on. And then it send this command to the corresponding IED of that particular device. So the device could be a circuit breaker or a transformer, right? Or any other device. So for an example, in here, we have a circuit breaker here, and there is an IED attached to this circuit breaker, right? So this command is going to that corresponding IED, yeah, intelligent electronic device, and then IED itself has a microprocessor or the some processing unit. So it process that command, and then it identify what's the operation is, and then it sends the actual signals to the circuit breakers to, let's say for an example, if it is to open the circuit breaker, it will send an open command, or it will do the actuation task. So it will open the contacts in the circuit breaker or the isolator, right? And then, so after performing that function, it also takes the status of this circuit breaker in our particular case. So it basically look at whether it's open or closed, right? So that information is coming as some sort of a digital input to here. And then it send it create a communication packet based on that information, and then it send the status information or status information to the bay controller unit. So the bay controller knows that the state of all the devices that it is being monitored and controlled, right? And that should also be visible in the SCADA system, or the visible to the operator. So the bay controller unit will send this status information to the SCADA system. So the operator can see visually the status of this device. For in our example, what is the status of the circuit breaker, whether it's open or closed, and that will be visible in the SCADA system, right? So that is the main function of the bay controller unit. So you can see it takes it's process the various commands coming from different inputs and take decisions, and based on that decision, it send the commands to the corresponding IEDs, right? And then the monitor the status of these the devices and send that information back to the SCADA system, right? So the local bay controllers, or the local controllers will only taken care of the corresponding devices attached to the units that are in that particular bay, or that belong to that local controller. Like for example, if you can go up, takes a little time. Right? Like for an example, so all the devices in here, their status or isolators, you have a couple of bunch of isolators here and bunch of circuit breakers here. So they are all the status and everything. And then you have the voltage and current transformers here. So they are the values and everything are monitored through this bay controllers, and then that will be displayed in the SCADA system, so that the operators can visualize the condition of that particular bay. Okay, right. So that's the basic function of the bay controller. So if you look at inside the bay controller, these are the things that you can see. So you have the electrical inputs, right? So basically current and voltage input modules are there. So you have the current transformers, voltage transformers, And then you have 16-bit high-speed A to D converters to control these the current and voltage values to uh, the digital values, right? And you have to have an isolation also for the protection purpose, right? And then if you look at the DC and analog input modules, right? So for an example, temperature sensors, pressure sensors, battery voltage sensors, and so on. So they uh, are coming from the external transducers. Typically, if it's a current signal, 4 to 20 milliampere. If it's a voltage signal, 0 to 10 volt, right? And it's do the scaling and filtering, and it also provide the galvanic isolation, right? And you can have the binary inputs, right, or the digital inputs, right? So these are basically coming from potential free contacts, right? And there's a high voltage isolation, right? There could be up to 124 channels in depending on the bay controller unit, right? And it basically monitors the status of circuit breakers, disconnectors, earth switches, alarms, and etc. Right? And the power supply unit is basically a DC operated 220 volt DC power supply unit, right? And you have the central processing unit to process all these the incoming signals, right? And that is typically 32-bit or 64-bit processor, right? And it's an industrial grade processor. For an example, it could be Intel Atom or 1.6 gigahertz Intel Atom processor, or any other type based on the bay controller unit, right? So these bay controller units have dual core systems for redundancy purpose, right? And executes control, operation, and interlocking protection and communication logics and everything. So it's process all the intelligent stuff in here. So in order to support this central processing unit, you need the memory, right? So these bay controller units have random access memory as well as the solid state disk, right? Depending on the bay controller unit, the amount of memory available could be different, right? So the RAM is basically used for real-time data buffering and the OS functions, and the SSD is basically used to store the firmware, the operating system, then the application logic, event logs, and so on, right? Other than that, the bay controller unit also have the non-volatile memory or the ROM, right? That basically stores the configuration files, fault reports, and so counters and so on, right? And real-time clocks are basically used for time stamping of the events, right? And we can also use the GPS and SNTP protocol to sync these real-time clocks with the centralized protocol. So you will have the system-wide consistency on the clock information, and that would be greatly helpful, especially when you comes for a fault analysis and so on. Like the sequence of the event can be clearly identified, not only within the substation but also within the other connected substation and the central control units, maybe far away from the substation. So entire system will synchronize for a single clock, right, by using this network time protocol and so on, right? And this bay controller units also provide the outputs, right? So it could be binary outputs modules to send the control command, right? So it provide high voltage isolation, right? And there could be up to 32, 38 channels, so they can basically send open close commands to circuit breakers, disconnectors, etc. Right? And also the indication alarm outputs are also there. So these are basically local LEDs or indicators, right? And some alarms that basically indicate any abnormal conditions in the system. Okay, and the one of the the important thing to integrate all these things and facilitate the communication between uh, the the bay level control units to the main control unit and beyond is the communication interface, right? So there are various different communication interface facilitating different functions, right? So this communication, the station bus, this SCADA system, they use this IEC 61850 and IEC 60870 communication protocol and DNP3, Modbus. So all these communication protocols are used, right? And the physical infrastructure could be 10 or 100 base, the TX means the copper, or 100 base fiber optic, right? And the process bus that basically use the IEC 61850 standard, right? So it sends these boost messages, right? And it's a very high speed peer-to-peer the communication, right? And then there are redundancy protocols, and there are other type of legacy communication devices like RS485 and GPS clock synchronization and so on, right? So there are various other communication protocols and communication modules associated with these the bay controller units. Okay. Okay, so we will quickly look at the intelligent electronic devices, right? So as I said, these are this gives some sort of a intelligence for the commonly or the what kind of say the primary equipments in the substations like circuit breakers, transformers, capacitor banks, and so on by using a microprocessor based controllers, right? So the key function of these intelligent electronic devices are to provide the protection, right? So to detect the voltages, currents, or frequency anomalies, and triggers actions like tripping circuit breakers to prevent equipment damage, right? And it can produce, it also produces the control uh, functions, right? So it issues the real-time commands to the field devices to regulate the grid parameters, such as the adjusting voltage by changing the transformer taps and so on, right? And it also facilitates the monitoring and metering, right? So which basically records the power quality, fault events, and system performance data, right? So there are different types of IEDs, right? So some typical IEDs that you find in a substations are protective relays, right? These are the most common IEDs used to detect the faults and isolate problematic sections of the power grid. And the voltage regulators are the devices that adjust the voltage levels dynamically to keep them within the safe operational limits, right? So like transformer tap changes, static bar compensators, and so on, right? And the circuit breaker controllers, so they are the microprocessors that manage the opening and closing of the high voltage circuit breakers. So these are basically for the maintenance and repair purpose. The other times the circuit breakers will be operated from the commands that are going from the protective relays and so on, right? And the recloser controllers, so these are the system that monitor the power line and automatically attempt to restore the power after the temporary fault, right? So you can now you have seen there are many devices included, or many many equipments included in the bay control, right? So you have the SCADA system, the bay controller unit, and the IEDs, different IEDs for different equipments, and so on, right? So you can network them in different ways, right? So IEDs can network in many different ways by using different network topologies, right? Uh, so this shows some of possible topology. So this is a single star topology. So you have the star coupler, and the SCADA system is connected through the big control unit or the star coupler, and then the different IEDs are connected through the star coupler to the HMI or human machine interface. So this is a double star topology. So you have a two star couplers and two star created, like kind of the the replication of the same star, but you have these two star couplers, right? And this is the single ring topology. So where you have Ethernet switches and Ethernet rings, and all the IEDs are connected to these rings, and it sends the messages to uh, the SCADA system or the HMI through this the ring, right? So it could be fiber optic or it could be any other medium, right? So the fiber optics are becoming more and more popular in the modern substation, right? So that's the bay level control, right? So uh, so what I will do is I will post the lecture at this point, and I will upload a different video talking about the next level. So going beyond the bay control to the station controllers and the centralized monitoring and so on.